Hello and welcome back. Okay, in today's video I'm going to continue converting the last few breadboards from the ALU into PCBs, focusing on the ALU Control today. So let's check the ALU still works. So the green lights you see flashing up here are the separate operations in the ALU. So the control circuit is turning 4 bits of output from pipeline stage 1, which identify the ALU operation, turns it into all the different control lines that are needed to instruct the other sections of the ALU to do their work. This video isn't supposed to give you a detailed explanation of how this works. Go and have a look at video 41 if you want to see this section of the circuit put together. But because it relies heavily on this diode matrix board up here, it's also worth taking a look at the 2 diode matrix videos that I made. Links are up here in the corner somewhere. So the positioning of the diodes on this grid is what actually defines the mapping between the operations list and all the control lines in the ALU. So we're going to need to be able to reproduce this logic on the control board. Okay, so this is the space I've set aside for ALU control. Now the control board on the main build is implemented by the diode matrix and a couple of extra gates taken from some of the other chips I had lying around the ALU to generate the ALU clock. The inputs are the clock and the 4-bit selection of operation. The outputs are the ALU clock, which is basically a clock line that just happens when the ALU is active, which is we have a non-zero value in the operation selection. I think I'm going to start off by taking the diode matrix . Okay, so that's the main operation chips. Don't think we need to display the inputs. Okay, so now let's derive that ALU clock. Now this select 0 line is going to be low whenever we're not doing an ALU operation, so it will be high when we are. So we want to invert that and OR it with the clock. Inverting it and ORing it with the clock is the equivalent to inverting the clock and then performing a NAND operation. Whereas this ALU active line we can just get by inverting this select 0. And then we've got an unused inverter here. And we need 8 output LEDs. It's going to be easier if I swap these to resistor array versions as well. Now, I did the big diode grid like this before. Basically did them completely separate and then just merged them up on the PCB. But this time round, I want to wire in actual SMD diodes, and I've got to encode the pattern of operations in it. These are the pull-ups. first few of these were really difficult, basically getting the first vertical and the first horizontal row in, but now it's getting to be quite straightforward. That is actually the guts of the matrix. I think particularly vertically that could be packed together a little bit closer if it had to be. Yeah, I think we need a slight little bit more room. Now, hopefully this is room to write the operation next to each of these. I am remembering that row 15 and row 0 aren't used, so I could get rid of them if I need the space. I think I'm going to have to get rid of these lines for it to not feel too cramped. I think I've got enough room to write the labels for all the operations. I just need to work out how to route this. Okay, before I route any more, I want to start thinking about the labeling I'm going to put on here. There's 14 different operations that are encoded in the control. These LEDs are going to light up when each of them is active. It'd be really cool if I could label the actual operation, because that's going to make decoding the processor's function when you're single stepping a lot easier. I think rather than adding labels, if I name the LEDs, that will make them easy to associate. Shift left, add with carry, increment, inc on carry, subtract with borrow, exclusive OR, and clear carry. Now, ideally I want to be able to justify this text, but there doesn't seem to be any option for doing that. So I think I'm going to have to do it manually. Let's treat that as a ruler. That's cool. Probably the toughest bit here is going to be getting the 14 control lines for the horizontal rows back down to the demultiplexer chips. Anything I'm worried about doing with this, it does potentially make the VCC side of this resistor array more difficult to solder. All of these control lines are where it's going to get tricky, and I suspect once those are done, the rest of this layout will be easy. Okay, I'm thinking it might be better to swap these two chips over. Well, that snapping is annoying. I've never done that before. I don't know how legitimate it is. Feels like it should be okay. That's the one that's not connected. Maybe better to bring some of these more direct. Okay, everything up here is done, apart from a bit of labelling. This is getting very tight down here. This looks like there's space for a ground line down there, but the snap is preventing it. So these four lines are basically the operation select. You need to come from over here. Getting a good ground connection here is going to be difficult. Ground is kind of separated off here as a bit of an island. Got to be very careful of that. Make sure it's well connected to all the other grounds. I could make the blue line go away just by joining that there, but that needs some attention paid to it. The ground line having a more direct route there is more important. It's this select 0 is going to be troublesome. Probably should have put a ground tie to the back plane up here somewhere. Not so worried about neatness because this will all be ground fill by the time it's done. These two control lines are going to be difficult to get out of here. Okay, so select 0 is an important line, but it's not as important as making sure we've got a good ground tie here. Now, I have been doing some experiments with tuning some of the edges on important lines like clocks. So I'm going to add an extra capacitor. I may not necessarily use this, but having the pads there is going to make life easier. Okay, wiring wise I think that's done. Doesn't seem to think there's any problems. Wish I knew what made this stuff drift off the grid. Most of it doesn't matter all that much. I am very keen on making sure the spacing between my boards is all exact. Let's get the fill planes in. That is going to be an absolutely beautiful PCB. Okay, let's have a look at this. Okay, so that is the fixed clock with the bodge replaced. And that is a beautiful PCB. Okay, you'll notice not all the diode pads have matching holes on the stencil, and that's because I worked out the patterning and created a stencil with the appropriate bits of pad removed to actually encode the right data into the diode matrix. Definitely need some more solder paste. This is not spreading very nicely. Okay, the other capacitor space here was the spare one I left tuning the signal. So this is a 74540. We've used lots of 541s before. I've only used the 540 in the diode matrices. That's because it has almost identical operation, but all the outputs are inverted. I think some of these pins on the resistor arrays didn't get enough. Now, at this point I have to fess up to something. My great shame, in the time delay between designing this PCB and receiving it for soldering, I realised I had made a terrible mistake and put all the diodes in the circuit the wrong way around. It was quite a simple mistake to make in hindsight, because I was just thinking of the logical flow of the signal and neglected to take into account, when I was orientating the diodes, the fact that this is an active low connection. If for any reason I have to redo this PCB, I'll obviously fix it, but it doesn't seem like a severe enough problem to respin the PCB for. Now I hope I got all of the diode positioning right to encode the right data, but if not, I should be able to track it down and reposition diodes manually. What we've done here should match the pattern. Those first few rows definitely do. The big thing to learn about this stuff is solder really wants to do the right thing. That's what the solder mask is for. I'm literally just touching those and they sort it right out. I definitely need new solder paste though. Kind of wish I'd got the gold plated contacts, because that would have shown up the pattern nicely. Okay, let's get the build back out and see if this works. Okay, so obviously we're going to have to pull a bunch of this out. So that's the logical carry. And that's the ALU clock, which should now be generated on this board. So a pin there should get the ALU clock out. Okay, lastly, the top two control lines control the addition in the ALU result. So I need to get those wires over here. Okay, I think that's everything. Right, let's give it a try. Well, that's not working. Did look promising for a moment. Okay, so that clearly gets to the end and doesn't stop. Now, I'm pretty sure the code there is a compare against 0. Can't remember how I implemented it though. So that's done with a test A, which is ALU op and. So this is the control lines the old one would have kicked out. Okay, so here we're outputting operation 10, and we are not getting operation 10 here. Right, so it's the ALU up here, 0, hang on. Okay, so this isn't working still, but it seemed to do an awful lot more there. It felt as if there was a loose connection there, which is quite worrying. Okay, that has executed successfully and come up with the right final answer. So that's simultaneously very reassuring because that's an awful lot of operations needing to happen and get exactly the correct result. It's also slightly worrying because I've not experienced dodgy connections like that with the turn pin headers. So hopefully that's going to be stable now, but it's slightly worrying. It's a little bit annoying that you can't readily see the connections. Longer? It is. Because obviously the marvellous thing about this is we can now get a direct display of the operation that's happening. It's just kind of entertaining when we're running at speed like this, but when we're single stepping, this is actually going to help us understand what's happening quite a bit. Can't wait to get this final PCB done. Okay, that is a really cool improvement to the looks of the system. It's going to help with debugging as well. And I think that's enough for today. So I'm keen to get on and finish the design of this PCB. Now there's quite a few different elements to this section. It's predominantly an add operation here, but you've also got the selection for the carry, which is what these two control lines are doing coming out the top of ALU Control. And then you've got all the handling for the flags. So you've got both the latch that stores the flags between ALU ticks, but you've also got all the logic that derives different values of the flags. So that's going to take a little bit of effort to put that together. I need to remind myself about some of the specifics of what's going on here, particularly the overflow flag. That was a tricky one. I may have to watch my own video again. Hope you found this interesting though. Thanks a lot for watching, and I'll be back again soon. All right, goodbye.